Hello everyone. In this video we are going to see why Tesla uses a 48 volt battery instead of a 12 volt battery. We are going to see the mathematical equation behind it, and we are going to understand how such simple mathematical equations enables engineers to take smart engineering decisions that brings profit to the company. So it all starts with a very simple equation, the equation of Ohm's law, which states that the voltage is directly proportional to the current that is passing through the conductor. You want to eliminate this proportionality constant. We can assume that capital R, which is the resistance, is the proportionality constant. So this is Ohm's law, that is V is equal to IR. Fine. Now what we are going to do is we are going to work out this equation for I. So current that is passing through the conductor is given by this equation V by R. So current is directly proportional to the voltage, and the amount of current that is passing through the conductor is inversely proportional to the resistance. Now keep in mind that the resistance is directly proportional to the length and inversely proportional to the cross-sectional area of the wire. Now we are going to see two cases. One is a copper wire of bigger diameter, and the second one is copper wire of a smaller diameter, and we are going to assume that both the wires are of the same length. So we will look case by case. So in the first case we are going to see a copper wire of a bigger diameter. Let us assume that in both the cases, both case 1 and case 2, the length of the wire is going to be the same. So let me draw a partition line here. Alright, so that demarcates case 1 and case 2. So case 2, it's a copper wire of a smaller diameter. So that you can see that the cross-sectional area in case 2 is not pronounced compared to case 1. The assumption here is that in both the cases the length is just going to be the same. Alright then. So in case 1, which is the copper wire that is encountered typically in cars that uses 12 volts battery. Okay. And in case 2 you are using a thinner diameter. So in this case, since you are using the thinner diameter, what is going to happen is the resistance is going to increase. Since the resistance increases, there is going to be a this is a drawback immediately. Yes, this is definitely a drawback. Because the resistance has increased, what's going to happen here is the current actually decreases, because current, you see, is equal to V by R. Because resistance increases, current has to decrease. So you actually want to make sure that the same current is maintained. So what you do is you increase the voltage in such a way that the current remains constant. Okay. So that is the important reason why Tesla has to increase its voltage, the voltage of the battery. So it uses a 48 volt battery instead of 12 volts battery. Very sorry about the background noise here. So there you can see the difference, that in the first case it uses a 12 volt battery, but in the second case, because you have decreased the diameter of the wire, the voltage actually has to be increased so that the current remains constant. Alright then, so in this case the voltage is increased 4 times, which means that the resistance increases by 4 times, and the resistance increases by 4 times if you reduce the cross-sectional area of the wire by 4 times, right? So it's 1/4 of the cross-sectional area of the wire is only used in case 2. So what is the immediate advantage here? The immediate advantage is you are using less copper because you have reduced the diameter of the copper wire. So you're actually going to use less copper so there is less wire harness there. Okay, so that's a big advantage for Tesla. So of course, two things that you have to keep in your mind. One is, by increasing this voltage, you have to construct and modify the batteries. So modify batteries. So definitely this is going to be one drawback. The second drawback is, according to Joule's law, the power loss is given by this equation I square R. That is the equation for power loss. There you can see that since you have increased the resistance probably 4 times, then the power loss is actually going to increase by 4 times, because the current is going to be the constant in both case 1 and case 2. So power loss probably is going to be 4 times greater compared to the power loss in case 1. 4 times greater according to this equation, yes. So this power loss is dissipated as heat, but these are the drawbacks. So maybe I can say drawbacks, so I can just draw a downward arrow, and let me draw an upward arrow indicating that if you look at the copper wire that is saved, copper material, okay, you are saving copper material. So all you have to do is take an analysis and find out which one is going to be greater, whether it is going to be saving the copper, or which one is going to be profitable, which one weighs heavy. So Tesla engineers should have done the mathematics and found that saving the copper wire, saving the copper material seems to be more profitable compared to constructing and modifying batteries, compared to constructing batteries and modifying them. And probably you need some enhanced cooling system in order to dissipate the heat. So maybe the power loss because of increase in resistance. Okay, fine. So that's the reason why Tesla is using a 48 volt battery instead of a 12 volts battery. So the advantage, this is advantageous. Okay, also keep in mind, this is an extra information, that is, decreasing the diameter of the wire always is not a good idea. Particularly when you are having a fuse for your electrical fuse in homes. Decreasing the wire diameter is always not going to be a good idea. The reason is because if you are using a thinner wire for the same amount of current, sometimes you are increasing the resistance, and as a result of which, what is going to happen is the fuse is going to, the wire, it just blows up. It heats up and it blows up. Increasing the diameter of the wire more than the recommended value is also not good, because the fuse is not going to simply work, right? So that also increases the power loss, because power loss is given by I squared R. So if you're increasing a greater diameter wire, then enhanced current flow means that if you're increasing by 4 times, then I squared means that the power loss is going to be 16 times. So which is a very significant value. So increasing the diameter is not a very good decision because of the I square R equation. Hope this is useful. Thank you all for your patience. Thank you so much.